Welcome to week 8, question 5. It says the unemployment rate as a percent in a certain city can be approximated by, and then we're given a function. It says x is 0, which is for the year 2000, and it asks us to find the minimum and maximum unemployment rate during this period. And that's between 2000 and 2014. So the first thing we need to do is understand that for minimum and maximum, again, we're looking at the derivative of this function, and we need to look at the function and identify what kind of function we have. So you can see that we have an exponential e term, and we also have that multiplied by negative x, and we have a constant. So really what we have here is a multiplication, negative x multiplied by e to the negative 0.5x. Okay, so let's start. We'll write down the function here, negative x times e to the negative 0.5x plus 5.8. So when we have this product, we're going to be using the product rule. So let's remember what that looks like. So you've got product u prime v plus v prime u. V meaning the second part of the product and u being the first part of the product. So let's take those parts of the product aside, of the multiplication aside, and take the derivative. So we have u is negative x, so u prime would just be negative 1. V is e to the negative 0.5x, so v prime is negative 0.5 e to the negative 0.5x. Okay, and then we're going to put those back into the product rule. 5.8 is a constant and the derivative is 0, so we don't need to have that included. Okay, so it's going to equal u prime is negative 1 times v, which is e to the negative 0.5x, plus v prime, which is negative 0.5 e to the negative 0.5x, times u, which is negative x. Okay. All right, so you can see that we have still e to the negative 0.5x terms here, and we also have a multiplication here, so we can multiply these terms together, and let's see what we get when we do that. So we have equals negative 1 times all of this, e to the negative 0.5x, and then here we have plus 0.5x, because we're multiplying those, e to the negative 0.5x. Okay, so now we can see that we have e to the negative 0.5x in common, so we could take that out as a factor, and that would leave us with this 0.5x minus 1, this and this, 0.5x minus 1, and e to the negative 0.5x. Okay, in order to find that minimum and maximum number, that critical point, we would set this function to 0 and solve. And in order to do that, we can imagine that if 0 is the product, then either this bracket must equal 0, or this bracket must equal 0, or they both can equal 0. So we can see that 0.5x minus 1, that would mean that x would equal 2. And here we would have to take the ln of e to the negative 0.5x, but we'd also have to take the ln of 0, and the ln of 0 is undefined, so that means that with this function, we literally only have one critical point. So is it a maximum or a minimum? Let's go to the second page here and see what we can find. So we determined by finding the derivative, setting that derivative equal to 0, and solving that we have one critical point, x equals 2. We need to just check and make sure that it sits within the range. So we have a 0 to 14, so 2 certainly fits in there. And now we need to evaluate it at this point. What we should do to determine if it's max or min, we're going to be looking at this number on a number line. So we've got positive 2, and we want to check our end point, so from 0 to 14. Right, so we have 2, we have 10 here, we have 14 out here, and we're going to be checking whether the slope of the derivative is negative or positive. So at 0, it's negative. We know that it's 0 at 2. At 10, we know that it's positive. And at 14 it is positive. So we could see that at 2 it looks like it's a minimum, and at 0 it could well be our maximum. Let's check. So we're going to substitute f at 0, so that's one of our endpoints, and we find that it's 5.8%. We're going to check f at 2, that's our critical point, and we find that that's 5.0642%. And if we check the other of our endpoints at 14, we find that this is 5.7872%. So wow, the values at 0 and 14 are very, very close. But we can see that at f at 0, we are going to have an absolute maximum, so that's in the year 2000. We have our absolute max, and here at 2002 we have our absolute min.